last part of section 1.4 is the objective 4, where we're fitting a regression line to a set of data, meaning they gave us real life data points that aren't going to be perfectly linear. So like if you were to graph these data points down here, it wouldn't be a perfect line, but it might resemble a line. And so what we have this whole idea is linear modeling, meaning we can come up with a line that's pretty close to a line. You're actually going to do this in chapter 4 in stats. The whole chapter is linear regression and linear modeling. So you're going to have a heads up on all the rest of your students or your classmates, okay? So it says when a real world model can be described in a mathematical language, we have a mathematical model. So that's why we come up with like, I don't know, like waitresses, like maybe their model for what they make is 5x plus 20, where they get $20 no matter what for coming in, and then $5 per hour that they're there, right? So we can come up with a linear model for a lot of real life stuff. So it says the mathematical model gives results that allow one to predict what will happen in real life or in the future, okay? So if the predictions are inaccurate, results of experimentation do not conform to the model, we have to start changing it or just throw it out. Mathematical modeling can be an ongoing process. So it says, in general, what we want to do is we want to try to find a function that fits as well as possible the given data, okay? Theoretical reasoning and common sense will help us with that. This is called curve fitting. It's one of the aspects of mathematical modeling. So sometimes it won't be a line, sometimes it'll be a parabola, like an arch, sometimes it'll be an exponential function. We'll see all of that when we get into those chapters that cover those graphs, okay? So what we're going to do is linear regression. It says, in this chapter, we'll explore linear relationships, because that's what chapter 1's all about, is linears. We will examine some data and related graphs of scatter plots and then determine whether a linear function seems to fit the data. A linear regression is a procedure that can be used to model a set of data using a linear function, aka a line. We can fit a regression line of the form y equals mx plus b to the data using linear regression on our calculator, okay? So in a nutshell, we kind of just jump in and do it. So let's go ahead and do example 6. It says the gross domestic product, or GDP, of a country is the market value of final goods and services produced, okay? So market value depends on the quantity of goods and services and their price. They want us to model the data in this table with a linear function using linear regression on your calculator, and then they want us to use it to estimate what the GDP would be in 2014. So notice the data only ranges from 1980 to 2010 and goes by fives. So say we're in 2014, 2019, I don't care, and we want to have an idea to predict this. So what we're going to do is in our graphing calculator, we are going to enter this data, okay? So was that able to work for you? Did you find anything? Okay, so in your calculator, what we're going to do is the very first button we're going to hit, guys, is the stat button right here. And when you hit stat, I know it's kind of dark, but do you see how it says edit and it's highlighted? Mm-hmm. So hit edit, because we want to edit what data we're given. So either hit 1 or hit enter. And I use my calculator a lot, so I have stuff automatically in my list. If the calculator you have is borrowed from someone, you might have stuff in your list. Either way, you guys are going to have to know how to clear out data, okay? So if you want to clear out data that's in there, you always just go and highlight your list and hit clear, enter, and it'll clear it out for you, all right? So in list 1, we're going to put our X values, and they were nice and said, okay, instead of putting the year like 1980, 1985, and so forth, just make it 1980 year 0, and then go from there, okay? So we're going to type in 0, enter, 5, enter, 10, enter, 15, enter, 20, enter, 25, enter, and then 30, enter. Is that okay? So anytime you do need to say, like, you make a mistake, you should be able to back arrow and type over it, or you can hit clear and rewrite it, whatever it may be. All right, so then in the corresponding list, list 2 over here, arrow to there, when you arrow, it should go up to the top. So with 0, what was the gross domestic product in trillions? 2.8. So we're going to type 2.8, enter, and then 4.2. And we're just going to enter those all in with their corresponding years. Is that okay? And to know that you did it correctly, you know, you should match up. Like, we had 30 years worth of data, so our last input was at year 30, and that kind of idea. All right, so the next thing we're going to do is we're going to do a scatter plot, meaning if we were to actually graph these, what would it look like? And what's nice is we can have our calculator do it real quickly versus us, like, here's the x-axis, here's the y-axis, and trying to plot our point. So if you notice right above y equals, mine's in blue, yours might be in gold or whatever, hit second y equals, And here's all the different plots you can have on. Mine are all off right now. So I want to choose plot 1, okay? So I'm going to hit enter for plot 1. And see how on is like being blinking right now? I'm going to hit enter, so I just turned it on, okay? So make sure it's on, and then we want to pick the scatter plot. These are 6 graphs that you can do using statistics, so we're going to actually use all 6 of these in Math 145. But for college algebra, right now we're just going to use this first one, so just arrow down and make sure the first one's highlighted and hit enter. And when you do that, it changes what it asks you below it, okay? So is your X list in list 1? Yep, that's where we put all of our years. Is your Y list in list 2? Yes, that's where we put all of our gross domestic product. And then the mark just means when you go to actually plot your points, do you want to use like this square, a plus sign, or a dot? I usually just go with what they have, okay? So the next thing we're going to do is we're going to hit second mode to get out of there. Second mode to get out of there. The next thing we're going to do is put y equals and make sure we clear out any kind of equations we already might have in there. So I'm going to hit y equals. Notice I have 3 equations already in there from last time. So I'm going to clear all those out before I graph. Okay, I'm going to hit second mode, which is quit, to get back to my normal screen. All right, so now we're going to hit graph, but I just want to let you guys know, right off the bat when we hit graph, you might not see your pairs. And there's a quick way to zoom into our data, okay? Because typically the graph is your normal -10 to 10 window on either axes, okay? And we graph off, off of 30 and so forth. So hit graph. See how you can kind of see some points but not all of them, and yours might look a little bit different than mine. Anytime you're graphing something using your stat plot, so whether it's today or later on when we do it for quadratics or exponentials, you can always hit zoom and scroll all the way down to 9, or you can just hit zoom 9. You don't have to scroll down to 9, okay? The 9 is zoom into our stats. And so when you hit enter, there it is. Is that what your guys looks like? So hit zoom, did you hit zoom 9?
No, that didn't show up.
Well, it might be hiding because we're at a weird, uh-oh. Oh, because your stat plot's off. There we go, we gotta just turn it on and on. And then we'll hit zoom 9. There it is.
Okay, thank you.
Gavin, you're good?
I'm good.
Is yours working okay, Shai?
Yeah.
Okay, perfect. So the whole idea is it a perfect line? No, but in general, do you kind of see a line forming? Yes, and so that's what linear regression does. It's going to come up with the best fit line, all right? So we're going to, now that we're okay with that, we're going to zoom out. All right, so now the next thing we need to do, you only have to do this part once, okay? So I am going to do it with you. Those that aren't here today, guys, we'll just have to remind them to do it. But we need to turn on our diagnostic. And our diagnostic is just a way to say once we find the line, it tells us how good that line is. All right, so follow with me. We want to get to our catalog, which is the very bottom button 0, but we have to hit second 0 to get to our catalog. So hit second 0. And this catalog is literally alphabetical list A to I don't know about everything your calculator does. But we want to get to the diagnostic. So we can scroll all the way down to D, or if you look right above the x to the -1 power, it has the letter D. You can click that to get to your D's quickly. Okay? So there's still a bunch of D's, so I'm going to scroll down to diagnostic on. And diagnostic off comes first because it's alphabetical order, but we want to turn ours on. So we're going to hit enter and then enter one more time so it says done. Do you ever have to remember how to do that again? No. Now that it's on, it's going to be on. Corey, this is perfect for you because we're going to do this for chapter 4 in stats. So now that yours is on, it's going to already be on and good to go when we get into this chapter in stats. All right. Are we ready? So this is the part you need to know, and it's all on the back. So I don't know if you guys have looked down the back of your notes. This is everything we've done so far, okay? So I like that you're following along with me and doing it today and not writing stuff down because everything's already there, okay? So now that we've put it into our list and we've seen it in a scatter plot, we want it to come up with the equation of best fit. So how you do that is you hit your, what does it say to do? Sorry. It says hit, no, I'm lying. It's the stat still, sorry. Stat. But instead of editing our list, guys, we want it to calculate for us. So just scroll over to calculate and see how it matches this part of our notes right here, okay? We want to go down to 4 for linear regression. But you'll see right below it, if we kept going, guys, there's quadratic regression, which is your parabola. There's cubic regression, which is the x cubed. We'll do all of that later in the semester, okay? So we're going to go down to 4. We're going to hit linear regression, and you can just hit enter, guys. And look what comes up, okay? If we did not turn on our diagnostic, the r and r squared would not have came up. And to you guys, those values mean nothing. It just tells you how good of a fit of a line it is. So think of it as a test score. If you got a 99 on your test score, you'd be really happy with it, which means this data is a very, very good fit for this line and vice versa, okay? So what we care about is, notice we have y equals ax plus b. That's very, very similar to y equals mx plus b, correct? So when they gave us a, they're really giving us our m, our slope. So they gave us the slope of 0.405. And then when they give us our b, they're giving us our y-intercept, b, of 2.13, and my math lab will tell you what to round to, okay? R and R squared, we don't typically do anything with it. It's just a measurement of how good your line is. But if my math lab asks for your correlation coefficient, they're asking for R. So we'll write that down. So go ahead and flip to page 3 again. What we want to do is we want to answer the question, and we actually have 2 questions being asked on this page. One is, what is the line of best fit? And 2, what would you predict the gross domestic product to be in 2014, okay? So what we found is we found a line, but instead of y, we're gonna write f of x equals mx plus b. But in this case, what is m? What is our slope? 0.405. Are you guys okay with that? So notice they're calling it ax plus b, but a is the value in front of your variable, so that's your slope. So this is 0.405x plus b. Let's round to 3 decimals with him as well. So plus 2.139. So that's kind of like part A. That's the line of best fit. All right? So what we found was the linear function that represents, in general, the pattern you see when it comes to the gross domestic product. So since we have a function, we can use it to predict or estimate. So part B wants us to estimate for 2014. Well, are we going to plug 2014 in? No, what do we have to realize was all these years, we subtracted 1980 from them. Like, how far is 2014 from 1980? How many years away is 2014 from 1980? What is the x we're going to plug in, guys?
Is it 34?
It is 34. Okay. So 34, because we did 2014 minus 1980. So what are we going to plug into our function? Just 34. So we're going to find f of 34. Meaning in our function, wherever we see x, we'll plug 34 in. So this is 0.405 times 34 plus 2.139. And you can just throw that in your calculator exactly like that. Let me turn, I think it's easier to see if that's off. Is that a little bit better? I don't know if that helps a little bit, but I think sometimes there's a glare. So our function was just from our calculator. F of x equals 405x plus 2.139. And then we said, okay, anytime we want to estimate, we have to figure out what x we're going to plug in. So they wanted to estimate for 2014, which is 34 years past ground zero, like 1980, right? So we just plugged 34 in, did the math. What do you guys get if you plug that in? So 0.405 times 34 plus 2.139. So let's just round to 1 decimal place, or I guess we can keep it like that. 15.91 trillion. Is that what you guys got? Like 15.909, I think is what it was?
Yeah.
And if you wanted to be that exact, that's fine as well. So we can say, well, this problem's old. We're in 2019. You could just do the same thing. You can say 2019 from 1980 is 39 years. So you plug 39 in for x, do the math, and you get to figure out, or estimate. After a while, though, things happen, right? So we're not going to use this model for like 2080, right? Because I'm sure things are going to happen in our life that will affect the gross domestic product. So you kind of keep that in mind, that this linear function is based off just these 7 data values. So if you start to get too far from it, you might need to come up with a new function to represent that data.